Problem number 5. Identify the equivalent and equal sets. Part A. B, where one set is 0, 1, 2 up to 5. Another set is 0, 1, 2, 3, 4, 5. C, one set is 2, 4, 6, up to infinity. Second set is 0, 1, 2 up to infinity. D, one set is 1, 2, 3, 4, 5 up to infinity. Second set is 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, up to infinity. E, where one set is negative integer. Second set is the alphabets. F, which is the set of all x such that x belongs to Z and x is greater than 4, equals to or less than 12. Another set is the set of all x where x belongs to natural number and x equals to or greater than 5 and less than 13. G, where one set is the set of first 9 whole numbers. Second set is 0, 1, 2 up to 8. There are two pairs for each part. For A, one pair is the even numbers from 2 up to 8. Second pair is the alphabet from A up to E. In B, one pair is the whole numbers from 0 up to 5. Second set is from 0 up to 5. In C, we have two pairs where one set is the set of even numbers. The second set is the set of whole numbers up to infinity. This is also up to infinity. In D, again we have two pairs. One is the set of natural numbers from 1 up to infinity. Second is the set of rational numbers from 1 up to infinity. In E, we have again two pairs. One is the set of negative integers. Second set is the set of alphabets from A up to Z. In F, we have two pairs again. In one set, x belongs to integer, where x is greater than 4, equals to or less than 12. In second pair, x belongs to natural number, and x equals to or greater than 5 and less than 13. Similarly, in G, we have two pairs. One set is the set of first 9 whole numbers. Second set is from 0 up to 8. So we're going to identify the equivalent and equal sets. Which are the equivalent sets and which are the equal sets? So let me check one by one. Number 1, where we have two pairs of sets. One pair is the even numbers from 2 up to 8. Second pair is the alphabets from A up to E. In equivalent set, we just only care about the number of elements. For the sets to be equal, we care about the number of elements as well as the nature of the elements. In this case, we have 4 elements for the first pair and 5 elements for the second pair. So it doesn't satisfy both equivalent and equal properties. Because look, in first pair we have 4 number of elements. In second pair we have 5 elements. In first pair we have even numbers. In second pair we have alphabets. So we need to check two things. If the number of elements of one set equal to the number of elements of another set, then we can say that it is equivalent set. Even if their numbers are not matching to each other, still they are equivalent sets. But in case if their number of elements are same and their elements are same, then they will satisfy both the properties. They will be called equivalent and equal sets. But right now it doesn't satisfy both of the properties. So we can write that it is neither equivalent nor equal. Neither their numbers are the same, nor their elements are matching with each other. So it is neither equivalent nor equal. Part B. Again we have two pairs of sets. Number 1 is the set of the whole numbers from 0 up to 5. 0, 1, 2, 3, 4, 5. Second set is also the set of whole numbers from 0 up to 5. So we can see here that in first set we have first 6 whole numbers. The elements are 6. From 0 up to 5 we have 6 elements. Similarly, we have 6 elements in the another set from 0 up to 5. 1, 2, 3, 4, 5, 6. So it satisfies both the properties. They are equivalent and also equal sets. So we can write that they are equivalent and also equal. As I said, we need to check two things. First, to check that whether the number of elements of one set equal to the number of elements of another set. If they are equal to each other, then it will be equivalent set. There are 6 elements in first set, and also there are 6 elements in another set. We can say that they are equivalent, but at the same time they have the same elements. We have the same elements in first set and the same elements in another set. It is a set of whole numbers from 0 up to 5. It is also a set of whole numbers from 0 up to 5. The difference is only that I put dots here. I didn't mention 3, 4. I just put dots here. So these are equivalent and also equal sets. Part C. We have a pair of sets. We have 2 sets. First set is the set of even numbers from 2 up to infinity. Second set is the set of whole numbers from 0 up to infinity. So we can say that these 2 sets are equivalent, but they are not equal to each other. They are equivalent only. Now you might be thinking that how? The first number in the even number is 2 and then 4 and then 6 up to infinity. Similarly, the second set starts from the beginning, from 0, 1, 2 up to infinity. So this set goes to infinity. This set goes to infinity. They go equally. After 6 we will have 8, and then we will have 3 here, and then we will have 10, we will have 5, we will have 12 here, and then we will have 6 here. So both of the sets go equally towards infinity. They are banging in infinity. Therefore we can say that they are equivalent to each other. Equivalent only in the number of elements perspective. But they are not equal to each other. Why? Because they have different elements. In the first set we have even numbers, in the second set we have whole numbers. So the elements are different. Therefore we cannot say that they are equal sets. They are only equivalent sets. Part D. Again we have a pair of sets. The first set is the set of natural numbers from 1 up to infinity. Second set is the set of rational numbers from 1 up to infinity. Now again look to the first set. It starts from the beginning. The very first number in natural number is 1. 1 and then 2 and then 3 and then 4 and then 5 and then 6 and then 7 up to infinity. Similarly we have 1 and then 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7 up to infinity. We can say that they're equivalent to each other because the first set goes to infinity. Second set also goes to infinity. The time when both of the sets go to infinity, they will be equivalent to each other because we don't know where the number stops. They're banging in infinity. I just showed 5 elements for the first set and 5 elements for the second set. The rest of the elements are not known. Both of the sets go to infinity, therefore they are equivalent. If you look to see, in the first set I just showed 3 elements. In the second set I also showed 3 elements. The rest of the elements are unknown. Here the series goes to infinity, here the series goes to infinity. Therefore they are equivalent only. Similarly, we can say that these 2 sets are equivalent to each other. Because we have 5 elements here in the first set and 5 elements here in the second set, the rest of the elements are unknown. Both of the sets are approaching towards infinity. So we can say that they are equivalent set only. They are equivalent only. They are not equal. Because remember, for the sets to be equal, they must have same elements in both of the sets. If you look to the first set, we have the set of natural numbers. In the second set, we have the set of rational numbers. Because here we have the set of natural numbers, here we have the set of rational numbers. Natural numbers and rational numbers are 2 different things. Therefore, we cannot say that they are equal to each other. They are only equivalent. E. Again, we have a pair of sets. The first set is the set of negative integers from -1 up to -500. Second set is the set of English alphabets from A up to Z. Can we say that they are equivalent and equals? No, they are neither equivalent nor equal. Because look, the number of elements in the first sets are 500. It starts from -1 up to -500. We have 500 elements in the first set and 26 elements in the second set. Because remember, the total number of English alphabets are 26. A, B, C, D up to Z. We have only 26 alphabets. So their number of elements are different. In one set we have 500 elements, in the second set we have 26. So we cannot say that they're equivalent. But what about equal? Yes, they are also not equal to each other because remember, in the first set we have different elements. They are negative integers. In the second set we have something different, which are English alphabets. So the elements of these sets are not matching with the elements of the second set. Therefore, we cannot say that they are equal to each other. They are neither equivalent and nor equal sets. F. Again, we have a pair of sets. The first set is the set of all x where x belongs to integer and x is greater than 4, equals to or less than 12. Second set is the set of all x where x belongs to natural number and x equals to or greater than 5 and less than 13. If you look to the first set, here x belongs to integer. But what integer? Positive integer, where at one side x is greater than 4, on another side x equals to and less than 12. The next integer which is greater than 4 is 5, which means that the starting value will be 5 and the last value will be 12 because x equals to and less than 12. We're going to have 5, 6, 7, 8, 9, 10, 11, 12. Similarly, when you look to the second set, it belongs to natural number. Which natural numbers? Here x equals to and greater than 5, which means that including 5, the starting value is 5, but less than 13. Less than 13. The natural number right before 13, which is less than 13, will be 12. If we have lesser sign, like x is less than, then we're going to go one value extra for the end. When x is facing greater sign, then we're going to go one value lesser. So x is less than 13 means that the end value will be 12. You cannot say that x is less than 11. Less than 11 will be 10. So here the starting value is 5, positive 5, and the end value is 12. Here the starting value will be 5 and the end value will be 12. So the two sets will be in this form. For the first set, which belongs to integer, positive integers, we're going to have 5, 6, 7, 8, 9, 10, 11, 12. Because right after 4, the next integer will be 5. So we're going to start with the 5, not with the 4, up to 12. Similarly here, it belongs to natural number. But which natural numbers? 5, 6, 7, 8, 9, 10, 11, 12. The starting value is 5 and the end value is 12. X lesser than 13 means the end value will be 12. The other value which is right before 13, lesser than 13, will be 12. So both of the sets have the same number of elements. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements for the first set and 8 elements for the second set. Therefore, we can say that they are equivalent to each other. But at the same time, they have the same elements. They have the same nature of elements. We have positive integers from 5 up to 12. Similarly, we have natural numbers from 5 up to 12. So both of the sets have the same elements. Therefore, they will be equal to each other as well. So they are equivalent and also equal. Now you might be confused that look, here x belongs to integer, but here x belongs to natural number. How we can say that they are equal? Look here, we have positive integers from 5 up to 12. Here we have natural numbers from 5 up to 12. We are only concerned with the elements. Whatever stuff you have inside the braces, you are only concerned with that thing. You don't care that whether x belongs to z, or x belongs to whole numbers, or x belongs to natural number. You are only concerned with the number of elements inside the braces and the nature of the elements, and that's it. So I can say that they are equivalent and also equal. Both of the sets are equivalent and also equal. G. Again, it is a pair of two sets. The first set is the set of first 9 whole numbers. Second set is the set of whole numbers from 0 up to 8. So the first set is the set of first 9 whole numbers. Here we have first 9 whole numbers. Here we have also first 9 whole numbers, because remember, from 0 up to 8 we have 9 whole numbers. Just count it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is the set of first 9 whole numbers. It is also the set of first whole 9 numbers. Look, it is not in digits, it is in descriptive form. So we have total 9 whole numbers, and here we have total 9 whole numbers. Therefore, they are equivalent to each other. But at the same time, they are equal to each other as well, because look, it is the set of first 9 whole numbers, not even numbers, the set of first 9 whole numbers. Here we have also the set of first 9 whole numbers. The whole number starts from 0, 1, 2 up to 8. So the same elements we have in the another set. Therefore, we can say that they are equivalent and also equal sets.